Today, we want to continue solving equations by performing inverse operations in reverse order. We talked about our major operations, our addition and subtraction are inverses, multiplication and division are inverses, and we talked about the fact that the inverse of an exponent is a reciprocal exponent. So if we have x to the third equals 8, the inverse of that is a 1/3 power. The inverse of an exponent is a reciprocal exponent. One thing we have to remember is that if we're going to use our calculating machine to type things out, we need to put our exponents in parentheses. Otherwise, the calculator will follow the standard order of operations, raise 8 to the first power, and divide the result by 3, giving us the wrong number. I want 1 divided by 3, and then I want that to be the x. So, some variations on this theme. The inverse of an exponent is a reciprocal exponent. Variation 1. Radicals are fraction exponents. Specifically, the index is the denominator. Radicals are fraction exponents. The index is the denominator. So if, for example, we want to solve the equation, the cube root of x is equal to 4, we want to read this cube root of x as x to the 1/3 power, so that the inverse will be a 3rd power. So we read this expression as x to the 1/3 power so the inverse is a cube or a 3rd power. Oops. Radicals are fraction exponents. The index is the denominator. Any questions? Variation number 2, even exponents don't respect negatives. Even exponents lead to 2 solutions. So if I take 3 squared is 9, and also -3 squared is 9. So if I have the equation x squared equals 9, there are 2 solutions, 3 and -3. Since 3 squared is 9 and the square of -3 is 9, x squared equals 9 has 2 solutions, +3 and -3. We can usually summarize this with a plus or minus. The number part we can get with the exponent like we normally do. So if x squared is equal to 25, the inverse of an exponent is a reciprocal exponent. Our calculator is going to just give us the principal one. So 25 to the 1/2 power. It'll always give us the positive one because we had to pick one for the calculator to tell us. It can't tell us two things. But we know that since since x squared is 25, there's always going to be two solutions. So we write plus or minus. One symbol with a plus and a minus, and we read that as plus or minus. Crammed it up against the equal sign. So we read that symbol as plus or minus. So the answers are plus or minus 5. It means there are two solutions, a plus 5 and a negative 5. This plus or minus thing is just something that we have to do with even exponents. So we only have to do this plus or minus business when we have an even exponent to start with, and we're solving for the base. Let's do a bigger one. So if x to the 4th is equal to 25, then I'm going to do 25 to the 1/4 power, and we're going to write plus or minus because we started with an even exponent. So 25 to the 1/4, 2.236. Four is even, so we need plus or minus. If we have an odd exponent, we don't need the plus or minus. Question? We wouldn't have a negative index. We could write a negative index, but we typically don't. We just put that in the denominator. So if it's a negative index, we're indicating a negative exponent. Negative exponents just indicate denominators. Uh-huh. Uh-huh. If you want to square -5, you have to square -5. This says take the -5 times -5. If you just type -5 squared, the exponent only applies to what it's right next to. It's only right next to the 5. So this is squaring the 5 and then making it negative as a separate operation. If you want -5 times -5, you've got to have parentheses. If you just have, if the second one, -5 squared without parentheses, is -5 times 5, -25. So if we have x cubed equals 25, I'm not worried about plus or minus because I don't have an even exponent. 25 to the 1/3 power is 2.924. Don't want plus or minus because we did not have an even exponent. When we talk about even and odd, you're only talking about integers. So if my equation has a 4th root of x, that's too much. Let's go 4th root of x is equal to 2. This is not an even exponent. It's an even index, which is not an even exponent. The exponent here is 1/4. So this means x to the 1/4 is equal to 2. So we'll say x is equal to 2 to the 4th, or 16. So in this case, the exponent is not even. So there's no plus or minus. That 4 is an even number, but it's not an exponent. It's the denominator of the exponent. It's not the exponent itself. It's an index, not a denominator. The index, no, because to undo the 1/4 power, it's 2 to the 4th. We're not worried about that. 4 is index, not exponent. So even integer exponents lead to 2 solutions. The difference between the index is just the denominator of the exponent. Right? The 4th root of x is x to the 1/4. If you have an expression that's something like the 4th root of x cubed, the exponent is 3/4. So the index is the denominator parts of the exponent. So if there's a radical, unless the numerator of the exponent is a multiple of that denominator, an even multiple, the exponent's not even. I'd be really sneaky if I said the 4th root of x to the 8th power, because that's just an x squared. That's just x squared with more steps. Going along with this exponent stuff, exponents can be negative. But the inverse of an exponent is a reciprocal exponent. -3 also has a reciprocal. It's negative 1/3. So 0.585. To change the sign of something on your calculating machine, if you're doing Texas Instruments style calculator, you want the minus in parentheses. This is the change the sign. This button here, we say both of them as minus because English is dumb. But that minus button between the plus and the times, that one requires two things. That's not just to change the sign. That is looking for something before it and looking for something after it. So if I tried to say, type 5 to the parentheses negative minus 1/3, my calculator gets confused because when you use that minus button, that's an operation. It's looking for something right before, and it says, I'm not finding anything right before. This minus here is a binary operation and requires something in front of and behind. And if we go to the error, it'll say, what am I supposed to do with this? And I highlight this, like, well, what am I supposed to do with this? I need to see something before that. Now it's happy because it says 0 minus 1. It's like, well, I can handle that. 0 minus 1. So that's negative 1 divided by 3, negative 1/3. 5 to the negative 1/3 is 0.585. So if you want to say, don't want to do all that, you would say 5 to the parentheses, change the sign of the 1, and then divide by 3. Use the change the sign button, not the minus button. Any questions? If your calculator tells you that you made a syntax error, that means you typed something that the calculator doesn't understand. Syntax is how you type stuff. And your calculator says there's a syntax error. It doesn't understand what you're trying to tell it. That makes sense? You have to remember that computers are very, very dumb. And if you tell them things slightly wrong, they won't understand what you're doing. Humans are a little bit better at that. When I'm like, oh, 5 to minus 1/3, you don't like have a syntax error in your mind. You say, oh, I'll just round that to what you must be talking about. How's everybody okay? It might be the case that I'm asking you to solve equations and I'll say something like this, show your calculations. What I really want to see, if you're going to show your calculations, this line right here is sufficient for show your calculation. You're showing me what you're going to type in the calculator. Usually in the solving equations department, I'll ask you to round your answer to the nearest 1,000. That is the third decimal place to the right of the decimal point. We need to be able to interpret what a negative exponent represents. Negative exponents make reciprocals. Negative exponents indicate reciprocals. So what that means is that if we have x to the negative third, that means 1 over x to the third. A negative exponent in the numerator is a positive exponent in the denominator. A negative exponent in the denominator is a positive exponent in the numerator. Note that in that second example, the negative 2 exponent is only attached to the x. So the x moves, the 5 stays where it is. 5 does not have a negative exponent. The 5 does not have a negative exponent. It's a wrestling class. If I want the 5 to have a negative exponent, so I flip the whole thing over, then I got to make the negative 2 apply to both top and bottom. I need parentheses. But in this one up here, the 5 does not have a negative exponent. I shouldn't write that out and then use the same stuff in close proximity. In this expression, the negative 1 applies to everything in parentheses, so I can flip the whole thing over. How's everybody okay? That class sounds more entertaining, unless it's like a fight going on. Yeah. I've lived in that apartment. I had an upstairs neighbor that was barefoot all the time, but when you're barefoot on carpet, you tend to like pound your heels a little bit more. And in the middle of the night, he just walk to the bathroom. He had to like run to the bathroom. It was always thump, 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 thump. It's like every time he went to the bathroom, it was an emergency. And I don't like knowing that much about my friggin' upstairs neighbor. Yep, that sounds about right. That sounds like a neighborly thing to do. Don't put your TV up against a common wall. That's it. Don't put if there's like a bedroom on the other side of the wall, your TV shouldn't go there. Don't mount speakers on your freaking wall. Ridiculous. There's your mistake, living near teenagers. So negative exponents indicate reciprocals. Radicals indicate fraction exponents. The denominator is the index. Note that this exponent stuff applies to solving for a base. So these exponent rules, where the inverse of an exponent is a reciprocal exponent, this applies to solving for a base. Where the unknown x is the base of the exponent. It's something else entirely if we're solving for the exponent, if the exponent is the variable. So the inverse of an exponent is a reciprocal exponent. This applies to solving for a base. To solve for an exponent, we need to use logarithms. We use logarithms to solve for an exponent. This is when the variable is the exponent. Everything exclamation points. I think because of the pounding upstairs, I feel like I have to shout. And that's how it shows up in the writing. I can't write all caps. I also think I've had an excessive amount of caffeine today, and so everything is coming out shouting. So this is if we're trying to solve something like b to the x, where the variable is the exponent, is equal to k. I don't want to spend a lot of detail on a lot of time solving for an exponent, but it comes up because we got to solve x squared equals some constant. So we should be able to solve 2 to the x equals some constant. It changes things around. With multiplication, the two things are both factors. They're sitting on the same level. But with exponents, the roles are very different. So the way it works is if you're trying to solve b to the x equals k, then x is log base b of k. This also applies if you're trying to solve for a logarithm. So they're back to wrestling again. So the way you pronounce that symbol is to say log base b of k. The b is a subscript. And then k is back on the normal line. So to solve for an exponent, the x is what we're looking for. We use log base b of k. This is how you rearrange the base, the exponent, and the constant. So if we get the equation 2 to the x equals 8, we know that the answer is 3, but to rearrange it in logarithms, we would say log base 2 of 3. The problem is, when we look at our calculator, we only see this one log button. This log button is log base 10. And you're like, oh, dang it, I need log base 2, not log base 10. So in this case, we'll use the change of base formula. Oh, yeah. So we have to trick our calculator into doing log base 2, because our calculator is like, oh, I don't know what you log base 2. So what we do is we use the change of base formula. We have to be sneaky about it. So what we're going to do is the log, that's our calculator log, of 8, close parentheses, and then divide by the log of 2. So I'll take the log of 8, close parentheses, and then divide by the log of 2. And that's how we get at the 3 that we want. So this is called the change of base formula. It's how we can use, it's how we can use the log button on our calculator to calculate the log of something other than log base 10. Log of k over log of b. The change of base. That's how we use the change of base formula to get the logs bases other than 10. So this is just how we use, this is just a change of base formula. This is how we trade our log base 2 of 8 for the log base 10 of 8. This is how the logs interact. The 3 is the solution that we're looking for. X is log base 2 of 8, which means 2 to the 3 is equal to 8. That's why I picked the 3, so we could, because we know that 2 to the 3rd is 8. Yes. No, as long as we're consistent in the base, because ln is also is a logarithm. ln is log base b, called the natural logarithm. So if I take natural log of 8, divide by the natural log of 2, I still get 3. As long as you're consistent with both of those, then you can use whatever base your calculator has. If you get some weird alien calculator where the log button is log base 7, that'll be fine. You can use log base 7. As long as you do both in the numerator and the denominator. That's how you change the different thing. No. Just because it came up in the solving equations, we haven't even got to the trig part of solving equations yet. Because we have to invert that as well. Now, some of you do know some secret math stuff, because you go over here and you go way down at the bottom of your math menu, there's a log base. This, if you use this command, you can do log base 2 of 8 with one button. But you still have to press the math button, then scroll to this. And you put it in a really jacked up order. You put the log base 8, and then comma, and then 2. So it's log of 8, and then it's like base is in caps. It's like, well, don't forget, it's base. So that one goes second. Log of 8, base 2, and that's like not how you say it. Maybe that's how they say it in Texas. I don't know. I've never been to Texas. I don't foresee myself going. Yeah, it's funny because like people used to make fun of Hewlett Packard made a calculator that if you wanted to do 5 plus 2, you go 5 and then enter, and then 2 and then enter, and then plus. You like put in the two numbers and then you tell the calculator what you want to do them. And people like hated it. It's like, oh, that's not, you don't do things in that order. You say 5 plus 2, just make it say 5 plus 2. And then that was at a time when this is what your scientific calculator looked like. And you're like, okay, you don't like the HP notation. I get that. Find the sign of 30. Well, you got to put 30 in and then press sign. Oh, fuck off. You're okay with them being backwards here, but you didn't like it when it was 5 enter, 2 enter plus. That you didn't like, but this you're okay with. You know what I mean? People complain about all kinds of dumb things because it's something to complain about. But I gotta say, even though I think this is really weird to put in the 8, comma, the 2, the base goes next, even though that's how we say it. If you had told me it was log and then in parentheses you put 2, comma 8, I would be really mad about that. Like, oh, that's not what we're trying to find the log of. We should ask, we're trying to find the log of 8, and then the base is like the second part. So even though I made fun of it, this does seem to make more sense. But anyway, that's neither here nor there. We use logarithms to solve for exponents. And we want this change of base business because it's just more efficient to be like log of 8 divided by log of 2. We do have to remember to close the numerator because otherwise, if we do log of 8 divided by log of 2, your calculator is going to take 8 divided by the log of 2 and then find the log of that, and which is not 3. So you need parentheses. You have to be very specific when you're talking to a calculator. It doesn't know how to understand natural language. If I said do log of 8 divided by log of 2, this is mostly what people would want to do. And on your calculator, that's non-scientific. You'd have to be like all 8 log. Where is that? 8 log divided by 2 log. So you'd have to type it in some weird order anyway. Because it's calculated. Some buttons, the binary buttons have a thing, and the button and the thing. But the other buttons just do the thing to the thing on the screen. All right, let's take a break, come back and see how we can invert trig functions.